We will move to the next is, that is estimation of linkage. So we have detected the linkage. Now we have to estimate its value. So that what is the linkage value? So the very important thing, that the phenomena of linkage can be observed only in the family segregating for each of the two genes pairs corresponding to the two observed characters. This means one of the two parents should be doubly heterozygous. So this statement is very important in case of, means for the purpose of multiple choice question and all. So one of the two parents should be doubly heterozygous. For example, there are three type of crosses. That is, first one is double back cross. Double back cross. So double back cross is capital A, capital A, capital small a, capital B, small b. That is F1 hybrid is crossed with AB. Okay. So this and the ratio is 1:1:1:1. And another type of, and this is if I take dominant parent. Okay. So here also the ratio will be 1:1:1:1. Just check. The gametes will be AB, and here the gamete will be AB, 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 small. So AB. Okay. Four type of means same one is two. So this is one type of example, double back cross. Then second one is single back cross. So if I consider single back cross in case of dihybrid cross, so this will be like so this is single back cross. See here, we are considering only one parent as a recessive. Okay, so the ratio will be 3:1:3:1. Or another type of this will be A B B cross capital A small b. So this is also a single back cross. So the ratio will be same, 3:1:3:1. And third one is F2 family. So F2 family, we know that this cross is simply the selfing of the F1 hybrid, and the ratio is 9:3:3:1. Okay, so these three type of crosses are there: double back cross, single back cross, and F2 generation, in which one of the two parent is doubly heterozygous. See here, this is doubly heterozygous. Here, this is doubly heterozygous, this is doubly heterozygous, doubly heterozygous, doubly heterozygous. So one of the two parents is doubly heterozygous. So the phenomena of linkage can only, matlab, this is a hard and fast rule, so that it can be only observed in the families which in which the one of the two parents is doubly heterozygous. So you have to remember this, that parent should be doubly heterozygous. So in multiple choice question, that is there linkage is present. So if they ask that AABB cross AABB, so this will be wrong because no one parent is doubly heterozygous. Like the option is capital A, capital small a into AABB. So also linkage is not present in this type of cases. So we have to just remember that the one of the two parents should be doubly heterozygous. Okay. Okay, get it? So we have to just check that the parent should be doubly heterozygous, one of the two parents, for for finding that there is linkages present or not. Now there are there are various method of detection or estimation of linkage. So we have to just to test for the linkage when the linkage is detected by its expected ratio, and step two is to measure the estimation. So the estimation of linkage would further depend on the link phase of linkage. So that we can say that the estimation of linkage is dependent on the phase of linkage. Phase of linkage, and there are two type of phase, that is coupling and repulsion. That is present in the doubly heterozygote parents. So in which we have to just consider which is recombinant type and which is parental type. So there are four type of, suppose this is my heterozygote parent. So this will produce four type of gametes: capital A, capital B, capital A, small a, capital B, small a, small b. So in which I will consider these are the parental type and these are the recombinant type. And recombinant type is produced due to the crossing over. Suppose now this I have considered that if this is, I have considered that this is the probability of P is the relative proportion, that P is the probability of crossing over. If I say that probability of crossing over, so if P is 0.5, P is 0.5, it means there is no linkage. So just remember this, there is no linkage. So it means that non-recombinants are likely to the, as the recombination in the independent, means there is, means all will be in same ratio. Non-recombinant will not are likely to as the recombinants. Non-recombinant are likely to the as recombinants, as in case of independent assortment, and so the ratio will be 1:1:1:1. So but when the linkage is complete, so if P is equal to 0, so it will, we can say that linkage is complete. There is no crossing over. Linkage is complete. So these are two important, this P is equal to 0.5, it means there is no linkage. P is equal to 0, then there is a linkage is complete, and we will get only non-recombinant type, means parental type, or means parental type. Okay, so this we can say that if P is equal to 0, linkage is complete, and if P is equal to 0.5, then there is no linkage. So P is equal to 0, that the linkage is complete. It means there is no crossing over, no crossing over. So only we will get only parental type. So we will not get new combinations, new or we can say recombinant type. So if we can say that there is no crossing over, so this will not get, only we will get this in case of complete linkage. Okay, got it. So now so if I write this capital A, capital V, capital A, small v, small a, capital V, small a, small v, and this if I write in coupling phase, in repulsion phase, so the probability, this is my in coupling phase, this is my recombinant, isn't it? So this I am writing p by 2, p by 2, and this will be 1 minus p by 2, 1 minus p by 2. So this is nothing but probabilities. And similarly, in case of repulsion, these are my recombinants. So this will be p by 2, p by 2, 1 minus p by 2. So this we have to remember. Okay. So these are the probabilities. This is general probabilities 1 minus p by 2, and p is what? The probability of crossing over. P is what? The probability of crossing over. So P is 0 means there is no crossing over, and the linkage is 100%. Is complete linkage. P is equal to zero point 0.5. It means there is no linkage. We will get all the four type of combinations, parental as well as recombinant. Okay. Any doubt? Any doubt?
No, sir.
So there are there are five methods of this estimation of linkage. So so better to complete in one go. So I will complete in tomorrow. There I'll just enlist that method of movements is there. Method of movements. Second one is maximum likely linear function. Third one is maximum likelihood estimator, MLE method. Fourth one is minimum chi-square method, chi-square method. And fifth one is product ratio method. So these five methods are there for estimation of product ratio method. So these five methods are there for estimation of linkage. Okay. So better to complete in one go so that comparatively you can understand that what method is for which condition the particular method is important, that MLE is important in which situation, minimum chi-square is important, or it is better performance of all the five methods in different condition and in different situation. So better to complete in one go. So I'll stopping today here, and we will continue tomorrow at the same time 6 o'clock. Okay. Okay, thank you. Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Okay. So I told you that for the estimation of linkage, first of all, the basic thing we will check that there should be a doubly heterozygous. The condition should be doubly heterozygous. Then and then only we can find that find the estimate means we can estimate the linkage. So double there was like first is double back cross. Double back cross, and in which the our setup is like capital A small a capital V small v cross A B. So this is double back cross. Similarly, single back cross will be also there. Single back cross, and in this two situations are there. Or we can say that and their expected ratio without linkage. So their expected ratio without linkage, अगर linkage नहीं है then expected ratio will be here it is 1 is to 1 is to 1 is to 1, and here it will be 3 is to 1 3 is to 1, and we know that third case is F2 family. So in F2 case, this is the selfing of our F1 hybrid AABB cross AABB, and expected ratio is 9 is to 3 is to 3 is to 1. Now due to linkage, this expected ratio will not come in this ratio. So some linkage is there, will be there. So for that, I told you that different methods are there. So this type of a capital A capital B small v is producing how many type of gametes? 4 type of gametes. So this will produce 4 types of gametes. Okay, and that gametes are capital AB, this. And we can say if there is a coupling phase, then these are the parental type. And this is parental type, and this is our recombinant type, or new means we can say recombinant type. And this is non-recombinant or parental type. And I told you that we have to check the probability of what crossing over, that is P. So that this will be 1 minus P by 2, P by 2, P by 2, and 1 minus P by 2. And that this is the probability of recombination, or we can say crossing over. So this is in coupling phase. And for repulsion phase, this will be P by 2, because this is our recombinant type in repulsion phase. This will be 1 minus P by 2, 1 minus P by 2, and P by 2. Okay. So this now if we consider male and female different, so the combination will be capital A, capital B, this small a, small b. Now for male, it will be 1 minus Pm by 2, Pm by 2, Pm by 2, 1 minus Pm by 2. If this is in coupling phase. Similarly for female, 1 minus pf by 2, pf by 2, f by 2, 1 minus pf by 2. Okay, so now this a type, the double recessive progeny, that double recessive progeny is what? AABB is then expected to occur in, it is expected to occur in how many cases? 1 minus PM into 1 minus PF by 4 cases. So in such cases, this AABB will be there, and the total probability of A or BB type, AA and BB type, will is 1 by 4 irrespective of linkage. If there is no linkage, then the probability of will be 1 by 4. Now if we subtract this 1 by, means if we subtract the expected occurrence of this one ABV from 1 by 4, then we will get 1 minus PM 1 minus PF upon 4. Now if I take 1 by 4 outside, then it will be 1 minus PM 1 minus PF. So this will be the, would be the probability, this will be the probability of which type of gametes? AB and small a capital B type. Means if we consider coupling phase, then this will be the our recombinant types. And finally for AB type, just a minute, someone wants to join. So this for AV, we will subtract from 1, and these type of AB and AB are 2 types. So we will multiply it with 2 by 4, 1 minus PM and 1 minus PF. And minus what? 1 minus PM, 1 minus PF divided by 4. So this will get the probability of AB type. Okay, after simplification, we will get this 1 by 4, 2 plus 1 minus PM and 1 minus PF. Okay, now if I consider that PM is equal to PF is equal to P, means the recombinant uh, probability P of male of female is equal, then our AABB type will be 1 minus P 1 minus P divided by 4. So this will be 1 minus P whole square divided by 4. Okay, got it? And second one is this type. This will be 1 by 4 1 minus P whole square, and for this will be 1 by 4 plus 1 minus P whole square. So this can be asked in the exam directly. Okay, and now if for simplification I replace this 1 minus PM and 1 minus PF is equal to theta. If I take this is equal to theta, then our AABB type will be theta by 4, AB comma AB type will be 1 minus, sorry, 1 by 4, 1 by 4, 1 minus theta, and capital AB type will be 1 by 4, 2 plus theta. Okay, got it? Any doubt in this? So now I can write here the table. Phenotypic class is AB, AB, small a capital B, small a small b, and our expected frequency, this will be 1 by 4, 2 plus theta, and this is 1 by 4, 1 minus theta. This is also 1 by 4, 1 minus theta, and this is theta by 4. So this, from this we will calculate our different methods of estimation. Now, first one method is method of moments. First method is method of moments. So this is the simplest method of estimation. So this is important point, that this is the simplest method of estimation. Now here we will equate by equating the observed sample movement to their expected value. We will equate expected, means suppose whenever in chi-square we see the observed frequency as well as expected frequency. Here the same concept we will use, that we will use the same concept. We will equate what the sample movements to its their expected value. So in which the first method is, in method of movements are there are two methods. First one is immersion method. Immersions method. So in this case, in this case of F2 family, the expectation of in the four classes are such that, and such that as theta is increased, those in the first and fourth increase. Means we have seen that this AB, so this is my parental type if I consider the coupling phase. So this will increase whenever our theta will increase. Okay, so we may take we may take the linear function E minus M, expected movements and my means movements and its expected movements. So E is equal to, we will take this difference E minus M, and E is what? Our A1 plus A4, A1 and A4, and M is what? A2 plus A3. That is our recombinants. Now, if I take the expectation of this difference, so this we will calculate E my expected value of E minus M. So this will be expected value of A1 minus A2 minus A3 plus A4. Okay, A1 minus A2 minus A3 plus A4. So now what is the expectation of A1? What is the expectation of A1? I told you that these are the expected values. So 2 plus theta divided by 4 plus, sorry, minus, and this will be 1 by 4, 1 minus theta, minus 1 by 4, 1 minus theta, plus theta by 4. So from here, we will see that this will come n theta. So this expectation will come n theta. Okay. Now this if we take this theta 1 for our immersion method, so theta 1 will be estimated value of this will be expected value of E minus m upon n, isn't it? So we will take we will take this not expected value, this simply E minus m upon n. So this will be a1 plus a1 minus a2 minus a3 plus a4 divided by n. So this is my first estimator, that is what from the immersions method, and the variance will be variance of theta 1, that is for 1 is I am indicating for first method, immersion method. So I and the formula of variance I told you that is I is equal to 1 to 4 mi ki square minus summation I is equal to 1 to 4 mi ki 2 whole power 2. And we know that for means to calculate the expectation, to make the expectation 0, we will find this k1 is equal to k4 is equal to 1 by n. Just like in earlier I told you to in chi-square check calculation, then this will be k2 is equal to k3 is equal to minus 1 by n. And we know that m1, m2, m3, m4. So m1 is what? 2 plus theta by 4. m2 is what? m2 and m3 will be same, that is 1 minus theta by 4, and m4 is what? Theta by 4. Okay, from here, from this calculation, we will calculate the variance of this, variance of theta 1 hat, and this will be 1 minus theta square upon n. 1 minus theta square upon n. कहाँ से आएगा ये? We have to put all the values mi ki, like this will be like m1 k1 square, like m1 k1 square plus m2 k2 square, likewise this whole square will. So after simplification of all this value, we will get this variance of theta 1, that is the variance of first method, that is 1 minus theta square upon n. Okay, now as this is a function of theta, actually we have what we have done, we have replaced theta is what? 1 minus pm 1 minus pf, or if the our probabilities are equal, then 1 minus p whole square. So this, if I calculate this p for individually p, then this is what? This is a function, isn't it? This is theta is a function of p. So for that, if I want to calculate the variance of, suppose this is a formula, variance of y is equal to variance of function of y divided by this derivative of function and dy whole square. From this we can calculate our this variance of p. Now variance of p will come like variance of theta upon 4 theta. And we know that variance of theta is what? 1 minus theta square upon 4 n theta. See, 1 minus theta square upon n is there, variance of theta. So if we calculate variance of t, that is the probability in this variance of our recombinant fractions. So that will be variance of theta upon 4 theta. That is 1 minus theta square upon 4 theta n theta. So this we have to remember. This we have to remember. Okay. Now if we are considering our repulsion case, this is for coupling. So for repulsion, this theta will be what? PM PF, isn't it? So instead of theta in coupling, we are taking 1 minus PM, 1 minus PF. That is for what? Which type of we are taking? See, 1 minus PM and 1 minus PM. That is for coupling phase and parental we are taking. In case of repulsion phase, what are our parental? What is our this is what in case of repulsion, this is what? P by 2,
Recombinant.
recombinant. So here we will take this theta is equal to PM into PF in case of repulsion case. So and if the frequencies are probabilities is equal, then theta is equal to P square. So variance of P will be variance of theta upon 1 minus 4 theta. This is in case of one phase is coupling and one phase is repulsion. So if one parent or one parent is in coupling phase and one is in repulsion, so उस केस में थीटा क्या होगा? That will be PM 1 minus PF. This will be the theta, or we can say PF 1 minus PM in this situation. Okay, just a minute. Now this is the variance of theta in case of this is a variance of P in case of if the one parent in it is in coupling and one is repulsion. Now second method is, so in first method we have to remember just this variance of P 1 minus theta square upon 4n theta, or this 1 minus theta square upon n, and these conditions. And what is the this method? What we are doing, we are just taking this linear function of a1, a2, a3 and a4, and we are taking this expectations, and after that we are calculating the variances. Now second method is linear function which is used in estimation of linkage. So when we employ the this linear function of the frequency, which is used for detection of linkage as a method of estimation, then in case of F2 data, suppose this is my linear function a1 minus 3a2 minus 3a3 plus 9a4. अभी हमने ये कैसे लिया? क्योंकि we have to remember earlier class in which I also make this plus minus signs to make the expectation 0. Just if I show you here earlier classes, just a minute. See here, we have we have make it this a1 minus 3a2 minus 3a3 plus 9a4 for linkage. Chi-square linkage we have calculated. Remember this. So we will take this linear combination. Okay, get it? So we will use this linear combination here. Yes. Now, if I calculate the expectation of x, then after simplification, I will get, we have to put this expected value of a1 minus 3a3, a2 minus 3a3 plus 9a4. And I have to put the values which I know that this is expectation of a1, 3 expectation of a2 minus 3 expected value of a3 and plus 9 expected value of a4, and the values I know that this is 2 plus theta by 4, this is 1 minus theta by 4, likewise this is, and after simplification we will get that n 4 theta minus 1. This is the expected value of x, n 4 theta minus 1. So that theta could be estimated from the equation. And अभी हम इसको if I take this side, then after simplification, what we will get, we will get our theta 2. Theta 2 will be, for theta 2 will be a1 minus a2 minus a3 plus 5a4 divided by 2n. कैसे ये आया, कोई बता सकता है कैसे ये आएगा? Can anyone tell me how this we will get? बोलो. See this.
सर x की वैल्यू पुट कर देंगे a1 minus 3a2.
Yes. See this equation. This is what expected value of x is, n 4 theta minus 1. 4 theta minus 1. Okay. Now this is what expected value. If I take this as an estimator, now if I take this as an estimator, then this will be equals to our x. Okay, so this n 4 theta hat minus 1 is equal to what? a1 minus 3a2 minus 3a3 minus plus 9a4. ठीक है, अभी यहां से suppose n I am taking this side, so this will be 1 upon n and this equation. Then 4 theta hat is equal to 1 plus 1 upon n, this equation. Theta is equal to 1 upon 4, 1 plus 1 upon n, and this equation. Okay, यहाँ से I will get this, after simplification I will get this theta 2 hat is equal to 2 I am writing for second method, a1 minus a2 minus a3 minus plus 5a4 upon 2n. You just try this calculation, that this will become like this. So this is my theta 2, and same we will calculate variance of theta 2. So variance of theta 2 we have to just remember 1 plus 6 theta minus 4 theta square on 4n. So and the same method will be there calculate variance from this I is equal to 1 to 4 ki mi square minus summation I is equal to 1 to 4 ki mi whole square. Okay, so from this we will calculate our variance. So this will be 1 plus 6 theta minus 4 theta square upon 4n. Just remember this. You make a list, means after all the method you just create a list, or means just make a small note and put only the variance, only the important things, variance and all, means what we are taking as a this value theta 2 value and its variance and important points. Okay, make a small note. Now third method is maximum likelihood estimator. Maximum likelihood method. So this method is means considered as a best method, because it gives, just generally whenever we find the estimator, then what are the property of a good estimator? What are the properties of a good estimator? Tell me. There are some properties of
Consistency and vastness, efficiency, efficiency.
unbiasedness,
consistent,
consistency.
efficiency.
Efficient,
Four,
sufficient.
four.
Yes, efficient, sufficient. So these properties, this whenever we use maximum likelihood estimator, it gives us all the criteria like consistent estimator, efficient estimator, and sufficient estimators. So that's why it's considered as a best method. So if someone asks that what is the best method of estimation of linkage, so this option is maximum likelihood method. So in this method, the likelihood of obtaining a family of size n distributed according to the multinomial law. I told you that if you know that multinomial distribution, just like binomial is there, multinomial is also there. So this here the multinomial law will be used in the 4 phenotypic classes, and with and this and the likelihood will be like L. I am writing likelihood for L n factorial upon I is equal to 1 to 4 a I factorial. This is observed frequencies. I is equal to 1 to 4 expected frequency to the power ai, mi to the power ai. Okay, so this sign is what? This sign is what?
Product.
Yes,
Product.
multiplication, product, multiplication. Okay, so this means it will be like n factorial upon a1 factorial into a2 factorial, a3 factorial, a4 factorial, likewise. Okay, into multiple m1 to the power a1, m2 to the power a2, m3 to the power a3, likewise m4 to the power a4. Now whenever we use the maximization, suppose I want to maximize this likelihood, I have to maximize this likelihood to. So for that, what we take the differentiation and we equate it to 1, equate it to 0. So for that, suppose for simplification, I will take first log of L, log likelihood. So this is for logarithmic of likelihood. So this will be, suppose this is a constant. So this will be our, and a power will come outside. Okay, this a log of m1 plus a2 log of m2 plus a3 log of m3 plus a4 log of m4. So I can write like summation I is equal to 1 to 4 ai log of mi, isn't it? I can write it like this. Now if I take the derivative delta log l upon, किसके रेस्पेक्ट में करेंगे? थीटा के रेस्पेक्ट में. So this will be I is equal to 1 to 4 ai and delta log of mi upon d theta. This will be equals to 0. This will be equals to 0. Just a minute. And its second derivative should be क्या होना चाहिए? Should be negative or less than 0. It should be less than 0 or negative. Okay. So for the maximum, now this is method log likelihood we have taken, and we have taken this, and the variance of this variance of theta will be, in this case, same method we will use, that is 1 minus 1 upon expected value of d square, that is del square log L upon del E square. Sorry, del theta square. Just a minute. This will be the variance, or I can write it minus 1 upon summation I and mi del square log of mi upon del theta square. So this is the variance. Now I'll tell you how to calculate this one out. So first, if I consider, which suppose I have considered maximum likelihood for double back cross. Back cross. So in case of back cross, what is that double back cross? F1 we will cross with our second parent. So this will be A, B, B cross small a, small a, small b, small b. So from here we will get F2 generation like A, B, A, B, A, B. These are the gametes here, and cross A, B. So this I'll get A, B, B type, A, B, B type. Okay, so if now this is our phenotypic classes like this. Then I can write this phenotypic classes, and in coupling phase and repulsion phase. In coupling phase, the probability this will be 1 minus p by 2, p by 2, p by 2, 1 minus p by 2. And in repulsion, it will be p by 2, p by 2, 1 minus p by 2, 1 minus p by 2. Okay. Now if I take generalized, so our phenotypic classes will be phenotypic classes is A, B, A, B, A, B, small a. And observed frequencies, suppose A1, A2, A3, A4, and its total will be n. expected frequency, or we can say expected proportion. Expected proportion. It will be m1, m2, m3, m4. ठीक है, और इसका सम क्या होगा 1, एंड एक्सपेक्टेड फ्रीक्वेंसी क्या होगी, दैट इज एन m1 and m2 and m3 and m4. So this sum will be n. Now in this case likelihood will be like n factorial upon a1, a1 factorial, a2 factorial, a3 factorial, a4 factorial, and this will be m1 to the power a1, m2 to the power a2, m3 to the power a3, m4 to the power a4. Okay, so and our m1, m2, m1, m2, m3, m4 are m1 is 1 minus p by 2, m2 is p by 2, m3 is p by 2, m4 is 1 minus p by 2. Okay, if I consider coupling case, now what will be the log L? Log L will be a1 log of m1. m1 क्या है 1 minus p by 2 plus a2 log of p by 2 plus a3 log of p by 2 plus a4 log of 1 minus p by 2. ठीक है, okay. Now we have to take derivative del log L upon del p. If I consider p here instead of theta, now it will be, what will be the derivative of this? Tell me. बताओ, मैं एक केस करके, one case I will do elaborately, and second you try by your own. Just tell me what will be the derivative of this.
a1 into 2 by 1 minus p into minus 1 by 2.
a1 upon a1 into
2 by 1 minus p.
how? What is the derivative of log x?
1 by x.
1 by x. So this is, suppose this is my I consider x, so this will be a1 upon 1 minus p by 2. Okay, and 1 p is also
Then
there
x
inside.
1 minus half.
Minus half, exactly. So this will be minus half. Similarly, a2 1 upon p by 2, and this will be plus half, plus a3 divided by p by 2, 1 by 2, plus a4 divided by 1 minus p by 2 into minus half. So now this 2 will cancel out. Will remain with what? Will remain with minus a1 upon 1 minus p plus a2 upon 1 minus p, sorry, p, a2 upon p plus a3 upon p minus a4 upon 1 minus p. See, p 1 minus p, I'll take LCM. So this will be minus a1 p plus a2 1 minus p plus a3 1 minus p minus a4 p. After simplification of this, suppose this is my del log L upon del p is there. So after simplification we will get like minus p a1 plus a2 plus a3 plus a4 plus a2 plus a3 divided by p1 minus p del log L by del. This is I consider 1. Then this we will equate to, किससे equate करेंगे? We will equate it to 0. Okay. So after equating it with 0, this will gone. Then we will remain with minus p. See here, minus p a1 plus a2 plus a3 plus a4 is equal to, this will be same, a2 plus a3. Okay, and this is what the sum is n. So p is equal to a2 plus a3 divided by n. ठीक है, सो दिस इज द p एस्टिमेट. अभी ये क्या है, अभी यहां से तुम चेक करके बोल सकते हो व्हाट इज p, व्हाट इज p, व्हाट इज p. p is the probability of what?
Crossing over, sir.
P is the probability of recombinant type. So see here, A2 and A3 are recombinant. In case of coupling phase, A2 and A3 are recombinants in case of coupling phase. So this we can remember. So the P is A2 plus A3 by n. Now if I want to for repulsion case, so what it will come? It will come a1 plus a4 divided by n, because in repulsion a1 and a4 are the recombinants. Just check it if you want to try. Okay, समझ में आया? Is there any doubt in this? Is there any doubt in this? No reply. Okay, no problem. Now second, we have to calculate the variance of p hat, and I told you what is the formula of variance, that is minus 1 upon expected value of double derivative del p square, and we have calculated already del log L upon del p is what? Minus a1 upon 1 minus p plus a2 upon 1 minus a2 upon p plus a3 upon p minus a4 upon 1 minus p. From here we have calculated this. See, this we have calculated del log L by del p. Now I have to calculate its second derivative. So just tell me what will be the second derivative. क्या होगा second derivative?
a1
Minus
plus a4
a1. सेकेंड डेरिवेटिव क्या होगा? इसका
minus
डेरिवेटिव
a1 minus
हाँ,
a1 plus minus a1 by p square.
1 minus p square
Yes sir, plus
then
a2
a2 p
by p
square.
square plus a3 by p square as
Sign will
plus
change. This
minus a3 by p square.
minus a3 by p square minus a4 by 1 minus p whole square.
सर a1 में प्लस होगा
इसको
और a4 में, a1 और a4 में.
no, all negative will come. Yes, all negative will come. So this will be minus, if I take common, a1 upon 1 minus p whole square plus a2 upon p square plus a3 upon p square plus a4 upon p 1 minus p square. Now, what is the formula of variance? If I calculate, that is minus 1 upon expected value of double log L upon d t square. So this I'll put the value 1 minus expected value of minus. So this minus will cancel out. This will be a1 upon 1 minus p square plus a2 upon p square plus a3 upon p square plus a4 upon 1 minus p square. Just a minute, a whole square. Now what is the expectation of a1? 1 upon expected value of a1 is what? In case of coupling, 1 minus p by 2. See here, I have written m1, m2. This is the expected frequency, that is n m1, and m1 is what? m1 मैंने बोला था क्या है? This 1 minus p by 2. So we will get expected value of this is n m1. Okay, n m1 1 minus p by 2 upon 1 minus p whole square plus p by 2 into n upon p square plus p by 2 n upon p square plus 1 minus p by 2 n upon p square. So this will cancel out 1 minus p. अभी क्या बचेगा लास्ट में? देन वी विल गेट 1 अपॉन n अपॉन 2 1 माइनस p प्लस n अपॉन 2p प्लस n अपॉन 2p प्लस n अपॉन 2 इंटू 1 माइनस p. ठीक है, अभी सपोज आई विल टेक दिस 2p इंटू 1 minus p as LCM, so I'll take this upper side 2p 1 minus p, and here I will remain with 2 1 minus p, so pn plus 2p n 1 minus p plus n 1 minus p plus np. ठीक है, कोई गड़बड़ हो तो मुझे रोक देना if there is any mistake. So this will be 2p 1 minus p upon c np plus n minus np plus n minus np plus np. This is cancel out. क्या बचा अभी? 2p 1 minus p upon twice n. This will cancel out. So the variance of p hat is p 1 minus p upon n. ठीक है, अभी तुमने have you seen that if you remember this ST means proportion, if you remember this proportion, then in that proportion case the variance is pq by n. Remember that in case of binomial distribution, if I consider, then this is p and 1 minus p, and we are taking now, if we are taking the proportion, just I am telling to remember how to remember this. This is very just like similar to the variance of in case of binomial distribution, p 1 minus p, so divided by n is there was, and nothing else. So p into 1 minus p, and this variance will be same for coupling as well as repulsion phase. You just try, I have done with coupling phase, you just try it with repulsion phase, so this will come same. Okay, variance of p will be the same in both repulsion as well as coupling phase. Okay, अभी 2 मिनट का रेस्ट लेते हैं, फिर आगे बढ़ते हैं फॉर F2 फैमिलीज। जस्ट मिनट। I'll be right back. Okay. Am I audible now? Am I audible?
Yes, sir.
Okay. So now we will see this maximum likelihood method in case of F2 family. I will not do the complete derivation because just the similar steps will come just like this I have done in back cross. Same, just the basic setup is in case of F2 family or F2 generation, F2 family. So we know that this cross is of A B B cross in F2 case. So we will get that our phenotypic classes like AB, 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 and small a, small b. This is my phenotypic classes. Then our observed frequencies. This is observed frequency A1, A2, A3, A4, and total is n. And expected proportion, what? That is M1, M2, M3, M4. Sum is 1. And expected frequency NM1, NM2, NM3, NM4, that is N. Okay. Now, and we know that in case of this, and I am considering coupling case, so M1, M2, M3, M4 is what? 2 plus theta by 4, 1 minus theta by 4, 1 minus theta by 4, and theta by 4. What is theta? Theta is equal to 1 minus Pm, 1 minus Pf. If frequencies are, means probabilities are of male and female are different. And in case of, this is in case of coupling, and in case of repulsion, theta is Pm into Pf. Okay, so these are what? M1, M2, M3, M4. Now again we will see what is our likelihood. This will be n factorial upon a1 factorial, a2 factorial, a3 factorial, a4 factorial, and here 2 plus theta by 4 to the power a1, 1 minus theta by 4 to the power a2, 1 minus theta by 4 to the power a3, and theta by 4 to the power a4. So we will see, we will take the logarithmic of log of L, and log of L will be a1 log of this 2 plus theta by 4. Likewise, we will calculate. Okay, then we will take del log L by del theta. So this will be, we will put equals to 0. Again, we will take this logarithmic like a means this will be, the derivative of this will be a1 upon 2 plus theta by 4, and here it will come 1 by 4. Similarly for all the terms. I am not going to prove this. कर लोगे ना? Okay. You just try that similar method will use just like a back cross. So final results I'll tell you. Final results I'll tell you that from there the variance will be, again the variance, we will calculate the variance, and the formula of variance is expected value of del square log L by del theta. So after calculating all the simplification and making the calculations, we will get variance of theta in case of this maximum likelihood estimator 2 plus theta, 1 minus theta, theta upon n 1 plus twice. So this will be the formula of variance in case of F2 family. In case of F2 family. Now variance of P हम कैसे निकालेंगे? Variance of P मैंने बताया, what was the formula of variance of P? That is variance of theta upon 4 theta. ठीक है? Should I prove this? How this 4 theta will come? Just a minute, I'll tell you. That we know that variance of P is equal to variance of theta upon del theta by del P whole square. Why I told you the formula of this generalized formula. So this will be variance of theta upon its derivative will be like, what is theta? if I put the value of theta, theta is what? 1 minus p whole square. If I consider the same frequency upon del p. So this will be what? Variance of theta will be same. This will be minus 2 1 minus p whole square, because we are taking the whole square of this whole square. ठीक है. सो यहाँ से हम अगर कैलकुलेट करेंगे देन दिस विल बी 4 1 minus p square, and 1 minus p is what? Theta. So this will be variance of theta upon 4 theta. Someone is yes. Okay. So this is variance of theta is variance of p is equal to variance of theta by 4 theta. So variance of theta is here 2 plus theta 1 minus theta into theta upon n 1 plus twice theta and 4 theta. So this will cancel out. This will cancel out by 2. So variance of p will be 2 plus theta 1 minus theta and twice n 1 plus 2 theta. Okay. So this by this type we can calculate the variance of this in our likelihood method. Now the next method is minimum chi-square method. Next method is minimum chi-square method. So in which, that is our fourth method, minimum chi-square method. So the chi-square statistic has been used for judging the agreement of observed frequency with the expected frequency in this 4 type of phenotypic classes on the assumptions that we earlier what we assumed that there is no linkage, but there is a linkage, so that's why we are going to estimate it. So if we take instead of the expected frequency based on the presence of linkage, the chi-square statistics would be a function of linkage parameter. And we will minimize this linkage parameter and this function, and after that we will get our values. So directly we have to that is very long and tedious derivation. I'm not going to elaborate this. So for that, in this method, chi-square and with 3 degree of freedom will be there, because 4 phenotypic classes are there, is equal to I is equal to 1 to 4 summation ai minus nmi whole square. This is my what? Observed frequency, and this is expected frequency upon nmi. Okay, same formula we are using, OI minus EI upon EI whole square. So this is observed frequency and this is our expected frequency. From here now we have to take the derivative of this chi-square by del theta, and we have to put it equals to 0 for calculating the same variances. So now directly I am writing that variance of this method is equals to the variance of minimum chi-square method is same as the maximum likelihood estimator. Same variance will come, that is our 2 theta 1 minus theta 2 plus theta upon n 1 plus 2 theta. Same variance will come. So which is leads to the means this same expression will come. So we can say that chi-square method as well as maximum likelihood method are will have the same efficiency. अभी हमको different 5 methods are there now. For efficiency, what we have to compare for calculating efficiency of something. What we will compare? Tell me. Variance. Okay. Then variance is, suppose I want to find the efficiency of any estimator. So we will take the ratio V1 V2. V2 of what? Which estimator we want to find the, suppose the, I want to find the efficiency of V theta 4. That is our fourth method. Yes, that is our fourth method, minimum chi-square method. So E theta 4 means I am going to calculate, then it will variance of theta in case of MLE and variance of theta in case of minimum chi-square method. So this is equals, so we can say that this efficiency will come 1 and the ratio is 1. Suppose I am taking this as a standard. So this is coming 1. So we can say that both are equally efficient. And the last method is, last method is product ratio method. Fifth method is product ratio method. Product ratio method. So in which, instead of considering the sum of our extreme frequency A1, A4, and we will take their products. So suppose I have taken the ratio of products, that is our phenotypic classes are like, this is A1, A4, A3, A2. So instead of taking the sum in earlier, you remember in first immersions method, we have taken E minus M. A1 plus A2, A4, and this A2 and A3. We have taken this, but instead of that, we will take product of A1 and A4 divided by A2, A3. Suppose this is lambda, some ratio of observed frequency of parental type divided by recombinant type. And we know that what is A1, A2. After calculating this, we will get this 2 plus theta upon 1 minus theta whole square. Okay, so this is value of lambda, theta upon 2 plus theta 1 minus theta whole square, by putting the values of all this. From this equation, we will get a quadratic equation to calculate the lambda. See here, 2 plus theta. Now this will be like, equation will be, I am not going to solve this. Equation will be like 1 minus lambda theta square plus twice 1 plus lambda theta minus lambda is equal to 0. So this is my quadratic equation. So from here we can calculate the value of theta and lambda. And the variance of this, variance of theta here will be same. We will calculate like again derivative of this equation and equating to 0. And the variance of this method will be twice theta 1 minus theta twice plus theta upon n 1 plus 2 theta. So what we are seeing here, the variance is same as likelihood and as well as chi-square method. So variance is same here also. So now we can say that our three methods, which method? Theta 1 is immersion method. Theta 1 is for immersion. Theta 2 is for linear function. Theta 3 I am considering for MLE. Theta 4 I am considering for minimum chi-square. And theta 5 is for product ratio method. Okay. Now we will compare all the 5 methods, efficiencies of different methods. Just this is very important, so listen carefully. Just let me draw a graph. Just a minute, the system is hang. Okay, so this is okay. Now as theta 3, theta 4, and theta 5 is what? Maximum likelihood estimator. Second one is, fourth one is minimum chi-square, and fifth one is product ratio. Its efficiency is 1. So that's why I have keep putting it here, that it is 100% efficient. Okay. Now see here, E efficiency of theta 1, E theta 1. If I want to calculate the efficiency of theta 1 with respect to E theta 1 will be, if I calculate the variance of theta in MLE and variance of theta in case of which method? Immersion method. Immersion method. I'll find here the variance of this efficiency. So after getting this, just you try this, after getting this variability, so whenever we will plot this theta 1 in case of our immersion method, I'll get this type of curve. So this efficiency of theta 1 will rise to 1 as theta approach unity. See here, this efficiency will reach 1 when this theta will increase. Okay, this theta will reach to the 1 here. Then and then only the efficiency of theta 1 first method will rise to 1 as theta approaches to unity. And this shows that theta 1 is fully efficient. Theta 1, it means theta 1 means which method? Immersion's method will be fully efficient for a very high linkage value in the coupling phase. समझ में आया? What is the link high linkage? यहाँ पे देखो coupling, this is coupling phase and this is repulsion phase. So this will be 1, efficiency will be 1 whenever whenever the frequency, or we can say that there will be very high linkage in the coupling phase. जब यहाँ पे high linkage होगा तब, so result क्या है? So we can say that what is the important thing, that the method of immersion method will be fully efficient as MLE and all, efficient for a very high linkage value in coupling phase. So this is our first important result regarding immersion method. See, very high linkage means the probability P is equal to 1. Then and then only this efficiency will be as similar to the maximum likelihood estimate. Now see this for the second method. The efficiency E theta 2. Now we see that it will reach, this theta 2 will reach 1 at which point? 0.5. ओके, यहाँ पे इसका एफिशिएंसी सबसे ज्यादा होगा. So theta 2 E theta 2 approaches to the maximum value 1 as theta reach to 1/4 from either side. So second result is efficiency of second method, that is linear function method, it will be maximum as theta will be 1/4 from both the side, from either side. See here, the value of theta will be at 1/4, then it will be our this maximum frequency, maximum efficiency. This means absence of linkage. I told you when P is equal to 0.5, P is equal to what? For P is equal to 0.5, बोलो. there will be no linkage. So I can say that if there is no linkage, then this method will be equally means high efficient. Or we can say if the linkage is very poor, in case of, I can say that in case of very poor linkage, which method is more efficient? So for very poor linkage, we can use our linear function. As theta approaches to 0 or 1, then our efficiency of theta 2, the value of theta approaches to 0 or 1, the efficiency of theta 2 means I can write efficiency of theta 2 will fall down. So these are the some results regarding this graph. Just a minute, few results are more. So suppose somebody asks that in case of linkage is very poor, which method is efficient? Then we will say that linear function will be efficient. And in case of uh, immersion method will be fully efficient when there will be high linkage in case of coupling phase. Okay, so from this graph, questions can come from this type of means this type of question, in which condition which method is efficient. Okay, any doubt you can ask me. If there is any doubt you can ask me. Another important point is that chi-square method can be used in both detection and estimation of linkage. So this is important, estimation of linkage, क्योंकि हमने स्टार्टिंग में देखा था in the detection of linkage we used chi-square. Okay, and estimation also we have using minimum chi-square method. So this chi-square, so in question it can come like which method is useful for both detection and estimation of linkage. Then another important point, just let me check. So that's enough. So is there any doubt you can ask me? For today's I have completed my from my side. All the 5 methods we have completed, that estimation of linkage, its variance, is there any no doubt? Then we will stop here. Okay, I think you should give some response.
No doubt, sir. Thank you.
Okay then.